Good morning, everybody.
Good
Actually,
morning.
I'm working in
Good morning.
TIFAC-CORE in Automotive Infotronics. It is a center in VIT, especially Vellore. In this TIFAC-CORE, they are doing this research in Automotive Infotronics. Basically, the Automotive Infotronics means we have the communication in vehicle. There is so many protocol to communicate with the sensors in our vehicle. Okay. Okay. So I have work in that area. I'm going to show about what are the data science we have work in TIFAC-CORE. Okay. Basically, it is my understanding of data science. But the data science is a study of extracting insights from vast amount of data using various scientific methods, algorithms, and processes. Actually, this data science is not a solution. Actually, it is one of the study to find out the solution. But it won't give you the direct solution of that. So, in our data science, we have some problem how to be structure it, how to be work with that, so that they're giving that what are the methodologies to do to find out the extracting the insight. The insight we see that there will be the insight to be having extracting insights. But the insight is the unknown we are seeking. This is a solution. We don't know. But we are extracting. We want a solution. But we are going to study. So what are the way we are studying that? They are giving that there is a scientific method, there is a algorithms, there is a process. Right, sir. About the scientific method, what are the steps will be there? There will be first one observation, second one question, third one hypothesis, fourth one experiment, fifth one conclusion, and finally the result. So what it doing that observation? We have one of the problem. What we are observing? What are the data we having? What are the methodology? What are the resources we are using? And what are the article? What are the existing method we already have? This kind of observation. First, in this observation, we need to find out what are the questions that is a highlight. Basically, we are expecting that I want in the low cost model. Okay, that is the question. How we can do? Whether it is mission critical or it is a normal application. If it is normal application, we can use something. But whether it is mission critical, we need to go to the particular high-end technology likewise. So that in this question, after that, we are having some of the assumption whether we use this kind of model, whether we use this model, whether we have the tree basic of a model. So one problem, we are not have one single solution. We have multiple solutions so that we are going to study to extract the insight. So we immediately want to get any solution. We need to go step by step of the study. Maybe it is going to 1 month, going to the 3 months, going to 1 year or 2 years. Depending upon the problems we are facing. We are getting from the client or from the university. For me, I'm getting from university. They are giving that problems from their own kind. Based on that, we are doing this kind of methodology. After we have assumption, I'm going to some experiment. In this experiment, first level I get such as, but sometimes we need to do 3 to 4 level of experiment. We need to do again and change the model one by one. But here is the cost is so important. Whether it is a success, whether it is a failure. But what are the way is optimized to find out the okay. That is experiment. After that, after the experiment, we found one way in this three type of all that. Okay. In this three type of all the experiment, finally we have to stay in one particular way of methodology. That method is a conclusion. In that method, whether we get the expected result or not, that is the final one. So in this scientific method, in this several step, in this experiment, in this conclusion, we decide we are going to work with this method. So we are going to type the coding, that is algorithm. So algorithm is just a step-by-step rules. So you give the input, what are the desired one, that is output. It's not a guess. So the final one is the process. What are the steps we are going to do? What are the input? Whether it is human being, whether it is mechanic, anything you giving that we need to get the product. That is process. So this is a data science. So first of all, it is not a right solution. It is the study to find out the solution with the several methodologies. Here, this technique that requires three major components: first, knowledge; second, mathematics, statistics, and probability; and third one, programmatic skill. This is the three important steps to achieve the data science. And there is a statistics, visualization, deep learning, and machine learning are all important concepts in data science. Okay. So you have to visualize the data, you have to use some machine learning model, or sometimes you are going to the deep learning. Why we require? Next slide, I am going to show you that what are the existing problems which I have work. I'm going to share with you. Okay. Based on that data science step, I have to structure it. Actually, there is a curve direction and warning system on Indian roads. You can see that image of that. We have some Google data. In this Google data, we have some judgment points. Judgment points means basically Google is drawing over the satellite image as a human being drawn over there. So that there is 50% not accurate, because you see that the actual road is here, they're drawn here. So whether self-driving vehicles trust with that one, it is surely going to the accident. So this kind of data we have, we get the problem is many people are killed in road curve accidents. And there is a need to develop a low-cost product that warns driver when a curve is approached. It need to alert me before I am reaching the curve based on the dynamic speed. I'm going to 100 km. The curve is just 20 km. I'm coming to 100 km. In this optimized location before the curve starting point, I'm able to control my vehicle. This will be all right. So we have the problem here. What we have to observe, how we are observed in this problem, whether we go to the satellite image or Google Map or some other open source map programming like OpenStreetMap, several things is application is there. And we are going to, I'm mentioning about IEEE, Elsevier, Springer, whether they're giving any solution or not. Okay, if it is optimized, it is able to do, we can follow that methodology. In some case, they are asking that we need to work with the high-end technology. Sometimes they are asking you need to establish sensor unit wherever the sharp turn is there. When our vehicle is moving, that it connects to the sensor unit and it will be get alert and we can automatically control speed. But in our road, there is so many curves, but how many sensor unit we have to establish? We require some low-cost product. It must be working for 2,000 rupees mobile phone. It must be working for Raspberry Pi. How to do? Okay, fine, we can. So that is the question is, what are the low-cost technologies? So we need to find out the curve. How can we find the curve? What are the input? Okay, whether we go to the satellite image, from this image processing, you need to extract where are the road. Here, where are the road in the satellite map to extract from that? We need to draw the road. From there, we need to find out where are the curve. It's too complicated because it's not able to process by the Raspberry Pi or low-cost Android mobile. So we can think about, we use the Google data. We know about the source to destination. We can get the optimized route very well from where Chennai to going to the Ooty. It can be able to draw. Okay, that one we can get. So it is called the Google Direction API. By using the API, we can get the XML format or JSON format of the Google road segment point. Segment point means the point, all of them interconnect. They are drawing that over the image, one point, another point, onto drawing like a line. So there will be fixed the point that is a segment point. We extract all the segment point. For example, A, B, C. For example, here A, B, C. We take 3 segment point, and getting that there is a from here to here there is a distance A, C to B distance B, A to B distance C. By using that, we can to draw the radius of the curve. You have to draw the circle by using the radius. Same way, several segment point we can to draw the radius of the curve. Now, how can we? Because from Chennai to Ooty, there is so many segment point, but we want to only the curve existing point. We need to find. So where we have to set up, there is a 1,000-meter radius. So in our India, the 1,000-meter radius is the biggest curve. You see that in the highways. There is the biggest one is that they are the 1,000-meter radius. So we have to set up the 1,000-meter first. By using that, in this 1,000-meter radius, one curve. After that, from there, this one, how to take adjacent segment point. Based on the adjustment segment point, you have to draw several curves. Which curve is not coming belong to the 1,000-meter, we have to stop. So you have to get from starting point to ending point of the curve. This is just a very simple method of the curve finding. That's why simple curve finding method. And there is a Bayesian method. It is a probability. Why they are using? Someone is using that. Whether you see that some of the Google map, some road having some noise. Noise means is a point. Instead of straight one, they have some of the noisily small point. You can't see in a hill terrain curve, they have to so many small. That is a noise. To eliminate that noise, how can you eliminate that noise? They are using one of the Bayesian method. It is getting from the IEEE some of the paper. But that is complicated. It will be giving solution for that. But one more problem, we have to set up that 1000-meter radius. Whether it is coming to the hill, all the curve is 50, 100, 150. So what will be happen that the result will be showing instead of single curve, if you are giving the 1000-meter, it will be 10 to 15 curve will be coming to one curve. It is one of the straight line. It is not a. So how to do? We have to another solution. We need to recursively find out a curve again and split. How to split? To reduce the curve radius from 1000 to 500, 50, 150. So you have to split it off. Very simple method. Okay, based on that, it is one of the Hilter and Yelagiri here. Many people know about that familiar. That we have to done the field testing. What are the field testing means? Not only finding out the curve, we need to warn us how to. Once we have to develop the Android app. That app we set up the source to destination from our VIT. There is a field test. We have to VIT to Yelagiri. So in that location, it is automatically find the curve. It will be listed out. That list down is here. That means first curve, how many meters is 51 meter the curve. From the first curve to next curve, how many meters is there? And there is a status provider because once you pass to one curve, it will be pass. So what it do? The second one here, we have to test in our vehicle with the speed of 80 kilometer because in one particular curve, it is a 50 kilometer. When we are approaching 80 kilometer, how many meter before the curve starting point? Curve starting point is here. From here to what are the optimized dynamically calculate your current vehicle? That location you should be alert. You have to reduce your speed. And it next one it should be tell about there is a right curve is coming. Why there is a right curve? Suddenly you have to steer. Because in case of the rainy season or fog season, it is too dangerous in car. You cannot see 10 meters of the distance. That time, when you are approaching the speed, you should be alert us to reduce the speed and to tell about right curve. So immediately we have to ready to turn. Otherwise, we are not conscious whether the curve is coming. So that is this approaching. Okay. So based on that, we have to conclude that recursive curve finding. So several methods we have to test and to experiment. After that, finally, we have to conclude recursive curve finding by using the Google map. So we getting the result and to test in the field. The algorithm is curve finding algorithm, curve warning algorithm. So the process is using the Google map, data as input, the step-by-step process has resulted in a device that warned the driver before approaching curve. That is a product. We giving the Google data input, we get the product. We have to fix in the car. That's a product. So this is the curve direction and warning system. This is a data science. Okay, so in this data science, what are the data we have used? Google data. Whether we go to the image-based data, some problem is deduction of vehicle pedestrian and close movement alert at night time. We see some of the location. I have tested that Vellore location because several people are moving without any restriction. When we are going very slowly, we cannot predict in which direction they are coming. Suddenly going one of the. Can you see that image whether anyone is moving? Because there is a RGB, red, green, blue. RGB image not able to find out the particular object in night time. But what we automation, we have to use one of the specialist cameras, depth camera. Here we use the depth camera. What the output? It will be RGB-D. That is RGB-D. It is a 3D form. So we are getting the image with the depth as well we have. We are processing the 2D image, one of the platform. When the 3D is coming, we need to more resources like GPU later. So more costs will be happening. So how do we reduce the cost? By using this 3D image in the normal platform. So we need to transform the 3D data to 2D platform. Here, there is a 2D depth color map. To transform, however to transform that, there is a RGB image. This right side, you see that there is a color map. The color map is having that so many distance value. If it is very closer, there is a blue, light blue. And it is far, there is a red. So every pixel having the distance value. This distance value turned into the color map. So that we have to depth color map as a 2D form. So by using this one as the input, we can make training this 3D transform to 2D data as the input, so that we can able to predict any object in the night time. But the accuracy is only the 10 meters. So that I'm tested only the close movement alert, whether the vehicle is moving slowly in the traffic. So if it is going to the highway, it's not suitable. But the problem we are facing that there is sudden movement of the pedestrian and some of the vehicle is moving. There is so many images that some vehicle is crossing from. Basically, the rule is left to right. They are moving from the right to left. So how can we? This is this problem is only in the Indian road, basically. Okay, fine. So in this observation, we have to zero camera and another one is depth camera. Why this zero camera is the camera will be RGB2 image is basically making the mathematical form of the depth. But the depth camera is doing the same. With additionally, it will be emitting some of the beam to validate the distance. So that camera we have to use. Okay. Another one, there is an automatic marking tool. Here, when creating a sample for training, a human annotator marks the object in the image using a manual annotation tool. There is more time and cost involved, so that an automatic tool is required. So many companies, many employees working for the manually marking. This marking image later used to train and going to predict the object. For example, in this previous, this all object everything we have to mark manually and to train it. After that, it's going to predict. So if we are manually marking, there will be so many time taken. So how can we make it as automatically? Okay, fine. In this automatic, what other question is, if the algorithm is accuracy is high, then the annotation tool is reliable. So what is the reliability of this tool? How accurate it will be? How much percentage compared to the human annotator? One human annotator per day, one image, approximate average 8 object they have to mark with the properties. Properties means in which direction they are coming, in which direction they are moving, and whether it is a collision, it will be hidden by some other object or not. This is the properties. Why these properties means some other properties, whether the pedestrian is directed, in which direction they are moving, from north to east, and some of them is strange pose, whether they are carrying some of the object, because if the self-driving vehicle detect the pedestrian with a strange pose, it will be more alert. So that this kind of the properties. So the tool must be detect the locate the object, and automatically it need to properties generation. So we need to do object detection, we need to do object properties classification. And another one, whether the vehicle, preceding vehicle, oncoming vehicle, whether it is moving or not, in which lane it is moving. For example, lane 1 or lane 2. This is eco vehicle moving lane. In this lane, this object is coming in the eco vehicle lane. So for example, we take the value 0. So this object is directed in the eco vehicle lane. There is a -1, -2, +1, +2. So after it direct with the properties. So how can we direct the properties? By using the classification algorithm. The classification algorithm wanted to in which front or back view. This is one of the classification. Other one, whether it is movement or not. Are they moving or not? For finding out the moving, we require the tracking. One object we need to locate, we need to give some identification number, we need to track. Then only we can be able to predict whether it is move or not. Other one, lane direction. In which lane, eco vehicle lane, the object is moving. So there is required object direction, object direction, property classification, lane change direction, and movement direction. So by using every algorithm, accuracy, all of them is combined, which is the best algorithm. In this experiment, we have to test the hypothesis. For example, YOLO version 3, RetinaNet, both of them is for object direction. We have to test whether it's providing the highest accuracy. We have to select it. Object direction, object classification, lane direction, tracking. We have to combine all of them and to provide a reliable annotation tool. This one kind of application. Other one, the interesting one is during the COVID. Okay, many people know about the face recognition is using for the autonomous purpose. Yeah, I have developed that one of the shoe manufacturer. In that they're having employee, most of the people are uneducated. What they are doing, they are using the ID card, they swipe, and they want to speed it up. They want to take attendance on the fly. Whether they are entering by using the CCTV camera, need to take attendance. In this case, how can we make it? Here, before that, we need to take a sample. How can we take a sample? Because when they are coming, that they will be, whether they keep their face straight, they come in new form. So how can we get the sample of them? We had taken the 5 posts with the totally 15 locations. So because closer, far, far, from the far, there is a camera, from the far coming to closer, it need to predict. Okay, so that the different location. It's okay. It have done before the COVID. But the current problem is after the COVID, all of them wear mask. Okay, the issue is we cannot take again the sample with wearing the mask. And another problem is they are wearing not most of them wearing that N95, but all of them is not. All of them using for child of the mask, many design of the mask. How can we predict? How can we? We are on to coming. They are thinking about I got attendance, but the system is not able to predict because the mask design is different. Here we cannot take again the snapshot of the face with the mask. So what we do, we can some of the simulator. The mask simulator have to simulate the existing face. Like here. They have N95, many kind of masks we have to simulate. That image we have taken for training. Now the problem, again the problem is design mask. How can we increase? So in our human being, when we see one person, they are wearing different masks daily. How can we recognize ourselves? We are thinking, oh, this person. It take our time. Okay, so to eliminate this kind of problem, we have to simulate the mask with the person, but we need to produce many more design of the mask. That mask we need to attach with every image. For example, we have to simulate 100 different design of mask. That mask need to fix with the particular person. Person that we need to generate the training, it can accurately detect that person and to recognize it for the attendance. And sometimes, again, we have some problem is they are not having acknowledgement. You know about when you are swipe your ID card, you have getting acknowledgement, but that people are not able to get acknowledgement. So how can we make? So one of the screen, the camera, whether they see the camera, the face is direct, but it should be blurred. Why that blur? That people, why my face is blurred and seeing closely? Immediately to check out on it. Because they are uneducated. Okay. Okay. That is a face should be blurred and blue in color. If they are seeing closer, automatically it will automatically taken the, but it need to take a little bit time. Then only they will be feel, oh, okay, I got acknowledged. Okay. Okay, this is the review of the. Okay. Another one of the important one is medicine direction and instruction. We have many clinic, all of them we have done it for the pediatric. The doctor is writing the prescription. Okay, most of the people are not know about what they have written, and what are the medicine they need to consume, and how many units they need to consume. Okay, so one of the device we put on the table, they have put the prescription, it will be deduct and put to the medicine tablet, it will be instruct. Because the problem is many people are coming again and again to meet the doctor. So why? How to use it? One patient, the doctor is meeting 2 times. How to eliminate? One of the device we have to put on that. So that device, it having top camera and side camera. First, you have to put a prescription. It need to deduct what are the medicine and how much you need to consume everything. That prescription, only that pediatric doctor handwritten only deduct. If you put in this one, you cannot deduct. But how can we make it possible? I have another way. But what we have, before you put as result, we need to go for training. How can we make it training? Because the patient will be put to the bottle in front of the camera, not straight for the label. They will turn the bot. We see that. So how can it deduct? It should deduct. All the medical representatives to telling about, they can be able to deduct the particular medicine without the label. Because the size, everything is unique. For example, in pediatric, the particular medicine bottle with the size is unique. The same size bottle will be available in a different, for example, cardiac, they have different, but the same size of bottle will be available. Okay. Other one, tablet. You have to put any form of the tablet. So we need to rotate the device, putting the tablet or medicine to rotate it and take many samples. So one device is making the training, other device is doing prediction. In case this prescription is not a particular pediatric one, it is a general. How can we extract? We need to go to the OCR platform. From there, you need to deduct the text. You need to recognize the text. You need to deduct the recognize the handwritten of the doctor. And most of the case, there is multilingual. Because some doctor write in Tamil here. Tali Iruma. Because it is a Tamil language. So how it deduct with the multilingual? So we need one text deduction application for multi-language. So what are the algorithm we can do? Okay. Some of the algorithms craft likewise. What they do, just find out the text different from the space. Based on the text, it will be marked. That is object deduction. After that, there is a CRNN, is a text recognition. It can be able to recognize the handwritten. And finally, we need to key value extraction. So many steps. Another format. Okay. Okay. Other one, this area currently I'm doing self-driving application. Okay. It is my current work. The vehicle need to roam inside the campus. It should be transfer some goods or something, some of the books or some files from one building to another building. But the problem is on the way there is so many pedestrians roaming. So what are the methodology? How to is manage? And it need to go on the left side of the road. Okay. So what are the platform we have? We need to use some of the probabilitical math model like Markov decision process. So because everything is uncertainty, but in which time the pedestrian will be crossed, we cannot be predicted. So one of the decision making algorithm by using the probability basic and applying some of the velocity obstacle. Velocity obstacle means the obstacle is moving. That is called velocity obstacle. So we need to structure some of the rule. So what if the pedestrian is crossing from right to left? What should do? From left to right? What should do? Well, from left to right, the vehicle should be stop and to move. From right to left, it can slightly turn right and to move. Based on the several probability mathematical algorithm, we can navigate the vehicle on road of the campus. I'm not saying about the vehicle is going in the mount road. It is only in the campus road. Because we have to re-engineer the toy car, kiss ride on car. We need to re-engineer. Maximum 20 kilometer speed it can be moved. In rider car, it is 5 kilometer only. We have to re-engineering it to 20 kilometer because we need to transfer the goods within the time. When it's moving 20 kilometer, whether there is a curve is coming, we have to apply the first application directly to be controlled. Some other application, when the vehicle is moving inside the campus, that is called the automatic guided vehicle. So you see some of the warehouse, there is several objects carrying and moving. That is automatic guided vehicle. It will be moved with the on the guided mechanism. Guided mechanism means some of the aluminum rod or something, some tape they have fixed on the floor. So there is a cost is high when you have to transport from one building to another building. It should be moved on the road. From one building, it come out, travel on the road, and enter to another building. So what are the optimized way? Here I'm doing that guided mechanism that is visually. You are not fix anything on the floor. So you can use the Google data. You can draw the Google data all your building. It can move with that. So how it is? It will be moved with the some of the path tracking algorithms. That path tracking algorithm is a MPC. MPC, moral predictive control. This kind of algorithm can navigate what are the path you have established visually, where there it can move. Okay. Other one, some of the low speed direction, there is RTO from Vellore. They want to regulate vehicle speed, and they want to find if there is which vehicle is going high speed. So they have fixed the notice board. The car should be moved 100 kilometer. The truck should be 90, 80, likewise. But they are only controlling the from Ranipet tollgate to Varaja tollgate. So they want to apply some system. So we are communicating with the toll plaza. They won't support. They won't give any data. So what we do, we have to fix all the toll booth. We ton student have stand. Everybody is having mobile to enter the vehicle information. And we have to establish some cloud platform. The cloud platform is communicating like tollgate 1, tollgate 2. So there is a central cloud. And the cloud is communicating with the RTO server. Because to get the information about the particular vehicle, from RTO. So it have to share the, share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the RTO. So it have to share the information with the information about the vehicle from one toll gate, just store in the cloud. Another toll gate, just retrieve. In this platform, it is like applied in the Tirupati. You know about Tirupati, entry time and reaching time, you should be within the particular time. You should not go over speed. For that kind of methodology is applied here. Very simple. So we have to test within the 3 hours. So 3 hours we have some data with the ton booth. So from Ranipete and Palukonda, in several booths, how many vehicles have gone? Okay, all the vehicle is going that the people are just enter. From this Ranipete, one of the vehicle is coming high speed. It is reaching there. We have to enter. We can get how much time they are reaching. We have to calculate. We can find 2 vehicles. We have find on the spot. Okay, so now in this 3 hours we have this much data. When we have applied the 10 days, how much data will be there? It will be too big. So this big data is nothing but you cannot be able to difficult to process in the standalone database management system because the data is stored like vertical. Vertical means is stored in the particular PC itself. That is a vertical. So if the data is coming to the horizontal, it will be distributed. If it is a distributed manner, you can very easy to access. That is big data. So for processing the big data, how this big data is growing, there is a variety, volume, and velocity. Variety means you have to enter the test data. Sometimes you have to store image, video. This is a variety. And the velocity means how much time taken. You have to record 1 hour of data. That is a velocity. Based on the 1 hour, the volume size will be. That is a later one. Actually, this is a big data lab in my VIT. We have 21 PC with one master in this big data platform. So we have worked with the Hadoop platform. Basically, it uses the commodity hardware. Actually, what is the commodity hardware means it will be connecting like main switch, rack switch, everything is a node. Node means one PC. PC is like it is a Google node. Google node means one of the motherboard. There is a bunch of RAM and 2 processor and storage and power bank. This is a rack server. This rack server we have to put it here. This is called big fat black box. This is a container. This is so we can call one data center. This is a data center. So in this Hadoop, it having the HDFS. HDFS means a Hadoop distributed framework file system. What is the concept is moving computation is more efficient than moving large data. What is the meaning is we have several data from multiple locations. We can gather everything and put in here and to process. That is moving large data to one place. We have to transform the computation. We don't want the data. Data will be sit in that place. We just transform the computation. That's moving the computation. That is more efficient than the transforming the data. So if transform the data, there is so many bandwidth data will be going out, and time has taken more. Instead of going, if you are planning to transform the data, there is no need of the distributor file system because the core part of the distributor file system is you need to distribute the computation. For example, the computation we have to actually this is the architecture of the HDFS, Hadoop distributed file system. What it do? There is one of the master and several nodes. They are telling about name node and data node. What the data node? It will be split every data as a block by block. This block will be stored in every data node. And name node is just to remember about where the data is located. Just remember. Okay, you have 10 minutes. Okay, fine. 10 more minutes. Okay. Find a small jumble how to. Okay. In this distributed platform, you have to split the 1 GB of data as 20 MB, 20 MB. With for reliability, you need to make a replication. Replication means that same block should be copied for 3. And need to every block, one block is one data node, another block should be in the same rack, another data node, the third should be the some other rack. Why this platform? In that rack, particular node is failed, getting from here. If this entire rack is failed, getting from another one. What it to if the first rack is failed, it's going to the same rack because of the transform the data. You can see the transforming the data. Eliminating the transform. Okay. So in this distributed platform, one can, for small jumble, we have one file that having 2 copy. The block ID is 1 and 3. There is several data nodes. So the 1 and 3 is 1, 1 because of the copies 2. And 3 is here and here. And here is 3 copies. So 2, 4, 5 is, it will be distributed. Okay. Okay, the HDFS is just a distributed file system. You have to store, but we need to make a computation. No? Who will be take computation? There is a map reducer. So it is just transfer the computation to wherever the data is located. In this node having the particular data, particular block, that computation is transformed to that data node by using the map reduce platform. So it having job tracker and task tracker. So task tracker is making the computation like a map and reduce. What is the map and reduce? Is very simple. We have the input map 1, map 2, map 3. There is a 3 node having some test value. Map will be collect all this data and to sort it out. What it do that in this sort, where are the same key? Joy here, here. All of them is sorted out with the key. So in this reduce stage, it come to here, add every key as a single. So one key is having value. So this is a simple form of the map and reduce. Okay. Now in this architecture, and why we have to use the combiner? Basically, the mapper just get the data and passing to the reducer. Reducer is making computation. This is like data is transferred to one machine. It's not a distributed platform. So the combiner is one of the summarization. Summarization, what it do? Wherever the mapper is working in the same location, the combiner also working. Okay, very simple example. We have some data. There is a 4 to 5 data or 5 lakh data. That is not a matter. The mapper just read the data and the combiner what it do. Actually, this is calculating the average. How can we calculate average in the distributed platform? For example, we have 3 systems. all three systems having data, we need to average. What are the method we do? Here we to average, and to get here and to finally average. This is not our method. It will be wrong. What I'm doing that, from every one, I have to sum and I getting the count. How many data? Summation of data, count of the data. Summation of data, count of data. Summation, count. All the sum it. All the count, that's also sum it. Finally, you have to, this is a distributed transform map reducer. So what the combiner do, get reading all the data and making the sum and count. It will be passed to the reducer. For example, there is a three system having the data. One of the reducer is here, making the sum and count, making sum and count in the combiner, passing to the reducer. So this is the combiner. On the reducer, getting from the combiner all the sum and count. Finally, you have to total sum, total count, the average. This is a simple average. Same way, how can we do with the minimum, maximum? How can we do with the standard deviation? How can we do linear regression? How can we do correlation? How can we do the machine learning Bayesian? These are but I can show only one program. This is interesting one. Okay. We have one small mathematical difference. For standard deviation, the equation is sigma sum. There is x value minus with x bar mean. Okay. There is a x. We have to x minus with the average of that value. So how can, if we make this computation, you need to take 2 times the job. First time, the average calculation. Second time, you need to make this one. That result should be passed to another job. So taking more costs. How can we do an alternate way? That is this. Here, all this computation in the one job itself we can do. So this provides the result to the same. This is the actual standard deviation. So that is, this is a computation of that one, the equation for combiner, making that, and to finally we have to do that. Same way. This is a correlation. Correlation having some equation. In this equation, there is some data set. I am expecting that. There is vehicle information. There is mileage and weight of the vehicle. How two data is correlated? Whether it is correlate or not correlate. Correlate. There is a strong association or moderate association, weak association. What is the mean? If it is going up, that is increase positive correlation. And if it is coming down, it is negative. This means if weight of the vehicle is a rise, mileage will be down. This is a negative. This kind of the correlation. If some of the data not matching with that, that is no correlation. First, that data, how can we correlate by using this equation? Okay. Like a combiner, upper, reducer. Same way how to do. And this is Bayesian platform. Very simple one. I want to find out red color of vehicle. It is domestic and SUV, whether it is stolen or not. We need to predict based on the condition probability. Red, yes. Red in color with yes. So this means red, yes, 1. And red, yes, 2, yes, 3. 3 divided by how many yes? This is the condition probability of greater than yes. So this is and how can we make like a condition if it is red and if it is yes, and we need to increment. Based on that, we have to compute. Finally, we can predict it. This is a distributed process. Okay. Another one is mainframe. Why I'm showing that there is a difference between the hardware platform of the cloud in Hadoop as a commodity hardware and the mainframe. How it is a communicating? It is one of the Almira size. It will be equal to one data center. One data center I have shown you the container base. It is one equal one Almira. Here, the efficiency of this one is 99% under utilization. In this commodity hardware, for example, we am using distributed platform with your remote laptop. I want to store data in here. Whether you people not use, it is in the idle. The power is going, everything is a waste. There is no wastage in here because the hardware architecture is different. Not like the commodity hardware. It having that data will be splitted like this platform. This Almira size one having the processing unit and some of the computation only, not the storage. Storage is separately going to another one. So what will happen? Anyone can use this mainframe 24 hours. If one of them is idle, other will be allocated to the processing and connect to the data. Data is the separate. Okay, this is the mainframe. We had this one for the academic initiative. We have trained the student maximum 5 years of that. We have some of the moment. Okay, actually, it having the data in different format. It having the high level qualifier, low level qualifier, and it having this type of data sequential partition visa. Sequential means the old tape record. So how you access one particular song, you have to play it some of the middle you have to access. This kind of data accessing is sequential. Partition means it is like a folder type. And the visa means it is having some index. It is a special one. So it is automatically handled the big data during the year of 1960. Currently, the cloud platform is happening, but it's provided as a private cloud, public cloud, everything from the 1960. Okay. Actually, this is a PDF data set, like a folder type. From here, several members will be there. This is allocation of the data set. What we need to do, how can we allocate? We need to pay for allocation. How much we have to pay? For example, it having primary, secondary. Primary turn secondary to. This means if we allocate the track, I'm allocating not MB, I'm allocating the track. Cylinder, one hard drive, cylinder, there is a track. I'm allocating the ton track. Ton track of your memory. If I use the ton track, if it is full, what can I do? There will be from the secondary, from 2 means 2 into 15. So 30 track is automatically. At the time, if it is full, it is coming one by one. That is reliable of the allocation. Another one, there is some kind of program like JCL, that is a job control language. It is like a batch processing and interactive processing. Batch job what they do. For example, you getting some of the how much amount you have utilized in the end of the month. You getting the summarization. So it will be start. Today I have to write the program. I have to start, but it will be execute at the end of the day, end of the month. So this is kind of program. Simple program. I have time. The time is nothing but it will be sure about current time with the session. There is a time and service number on the session. Actually, the service number they are providing that if I type any command, each command getting the service number. In this particular command, I get any error, I can navigate that one by using the service number. So everything having that number. So apart from that JCL, for this JCL, we have some program like a COBOL, you know, but from very old one. Currently, they are using the COBOL programming too, because it is a good program and a more reliable program. So, and another one is CICS. This is interactive. You have to access the ATM. It is directly connected to the mainframe. This kind of platform is CICS. CICS means Customer Information Control System. Okay. Thank you very much.